Now that we have a handle on using addition and subtraction, we want to do the same thing for our other types of operations. So in this section, we're going to go through our multiplication and division skills. So the one thing you have to remember is that when we have repeated addition, we can actually condense that using multiplication. So to give you a quick example, if you did 7 plus 7 plus 7 plus 7, what you're really doing is you're adding 7 up 4 times. Okay. So yes, you could plug this into your calculator. 7 plus 7 is 14. Add another 7, it's 21. Add another 7, and this ends up equaling 28. Okay. But that's quite tedious to do. So instead, since I'm adding up 7 4 times, if I multiply 7 times 4, it'll give me the same result, 28. Okay. So repeated addition can always be condensed this way. So if you're doing something where you have to continually add the same number over and over and over, multiplication is going to save us a bunch of time. So to kind of really hone in on that, let's look at an example. Suppose you buy a grande cup of coffee at Starbucks every single day for $2.95. So you're just getting plain, basic coffee. We want to figure out how much would I spend on coffee in a single year. So what we would have to do, if you think of this in terms of addition, you're doing $2.95 the first day, $2.95 the next day, $2.95 the third day. And you would have to do this over and over, assuming that there's no leap years, a total of 365 times. So although it can be done with addition, it's very easy to lose track of this when you're going about adding it. So instead what we can do is we're taking the number $2.95 and we're adding it up 365 times. So instead we just multiply the two. And in return, that tells us we would spend $1,076.75 on coffee in a single year. Okay. So now suppose I switch to a tall cup of coffee and it's going to cost $2.65. Now I want to see what would I save after 1 year. So if I'm trying to figure out how much I'm saving, I can do this a couple different ways. Kind of the first thought process that most people have is, well, I already know how much I would spend getting the $2.95 coffee. Let's figure out what would I spend on this cheaper version instead. And then we'll just look at the difference of the two. So I'm going to split this in half to just show you two different ways. So our first way is the total we would spend on this tall coffee is we do the same thing. We're spending $2.65 for a total of 365 days. So we just multiply the two, and the amount we would spend on 1 year would be $967.25. Okay. Before, I was spending this $1,076.75. So our savings is just going to be the difference in the two. So we were spending $1,076.75. We're now spending $967.25. And when you go ahead and subtract the two, you would save $109.50. Okay. So that's one approach to this. We do have a second approach too. So again, my best recommendation is always go with your gut instinct. Try it out. It might work, it might not, but go with what you feel might be appropriate. Another thing I can do instead is I can just figure out how much money would I save for every single cup. So if we look at the savings per cup of coffee that we buy, originally we were spending $2.95. Now we're spending $2.65. So every single day we're going to save 30 cents. Okay. So our total savings then is 30 cents a day for 365 days. So if you take 30 cents and times it by 365, you end up with the exact same number, 109.5. Okay. So typically there's never going to be just one way that you can do these problems. There's going to be abundance to them, especially when we get into the word problems. So you're going to see we're going to do that a lot throughout these sections. And when we have time, I'll go about going both directions. So let's try another example, kind of relating to what we did in a prior video. So suppose a family makes $80,000 a year and their household budget is as follows. We want to figure out how much money do they spend then in each of these categories. So we're given this pie chart and we're told for housing, they spend 29% of their budget in this category. For leisure, 14%, food, 15%, clothing, 14%, auto 12%, insurance 9%, and savings 7%. Okay, so our total budget is again $80,000. So what I'm trying to do then is find the portion in each of these categories. So starting with our housing, our budget is 80 grand in total. And I want to find 29% of that. The thing you don't want to do is you don't want to multiply this by 29 because that's going to be a huge number. It should be a portion of the budget. So it should be less than $80,000. So instead, remember, we can write 29% as we move that decimal twice. 29% is the same as 0.29. So I'm going to multiply these two together. And what in turn that gives us is $23,200 spent on housing in a given year. Okay? So again, if you times it by 29, you would see it's like $2.3 million. And that doesn't make sense. So one thing you also really want to get in a habit of is just checking, is this even something that's reasonable? Because these are realistic problems. They should make sense in the context. Now, really, we're just going to kind of change the number that we multiply 80,000 by for all of the remainder of these categories. So for leisure, we need to find 14% of 80,000. So again, I don't want to multiply it by 14. I move that decimal twice. 14% is the same as 0.14. So if you plug this into your calculator, you get $11,200 spent on leisure. For food, that's 15% of our budget. And then 15% as a decimal would be 0.15. So multiplying these two together gives us exactly 12,000. Okay. For clothing, that's 14%, but really we've already done that for leisure, so you don't need to go about this process again. It's the same. So no reason to do multiple work. Clothing, we're also spending $11,200 on. For auto, that's 12% of our total income. So as a decimal, that is 0.12. And so multiplying these two together will give you 9,600. For insurance and savings, now you just have to be a little bit careful because these are 7 and 9%. So just to kind of zoom down a little bit. So starting with insurance, that would be 9%. So as a decimal, when you move that twice to the left, 9% is 0.09 in decimal form. So again, if you multiplied by 0.9, you would see it's a very high number. So this is $7,200. If you multiplied it by 0.9, you would see it was 72,000. And again, you have to ask yourself, is that reasonable? 72,000 out of $80,000 is a huge portion. So there would be a minor mistake in that. And then the same idea for savings, it is 7%. So 7 has a decimal right after it. So moving that twice to the left gives us 0.07 in decimal form. And so multiplying these two together, they save $5,600 every single year. Okay, so kind of the opposite of what we did last time. Now let's just go ahead. We talked about that specific property about addition being commutative, but subtraction not being. We're going to see the same kind of thing happens with multiplication and division. So for these two, we're going to evaluate each of these expressions, and we're going to see, do we get the same thing or do we get something different depending on the order? So for the first one, if I take -3 and times it by -0.06, when you take a negative times a negative, it's going to turn positive. And then if you do 3 times the 0.06, or just plug everything into your calculator, this ends up being 0.18. Now, if you switch the order and do -0.06 times -3, you still end up with exactly the same thing. Okay? So multiplication is going to be commutative. Okay? So the order does not matter for multiplication. However, for division, we're going to see the exact opposite. If you take 269.7 and divide it by 10, this is going to give you 26.97. But now if you switch the order and do 10 divided by 26.97, you're going to get a really small decimal, and we're not going to be able to write it all out. So I'm going to round to 3 decimal places. This is about 0.037. So division is not commutative. You have to be careful the order you put this in. The way that's also kind of easy to remember this is addition and multiplication look very similar in the signs that tell us to do this. Now I know for multiplication we have a couple different ways. You can just put 2 numbers next to each other in parentheses. You also can say something times something with a dot in the middle, but the X is also a standard for multiplication. So it's really just a tilted addition symbol. Now for the ones that are not commutative, subtraction is not commutative, so the order matters, and division is as well. So again, those 2 symbols look like each other. They both have that minus sign within it. But also for division, you have other symbols. So we have that slash to say one over the other, or for both of these, you can also put it in a fraction form. This is 269.7 divided by 10, so you can put it in this form as well, okay? So just be conscientious of the order. You want to make sure you're doing things in the appropriate way. Now for this last one, we're going to kind of still work with our multiplication skills, but we're going to look at taxes. So if you ever have looked at the IRS's website, you fall into a tax bracket. Now that bracket doesn't necessarily mean that you're going to be taxed at that rate for everything. So say you make $50,000 in a year, portions of your money are taxed at different rates. So for this one, we're going to work with much nicer numbers than what the IRS has. But they tell us that Dion made $8,000 in taxable income last year. The tax rate is 15% for the first $7,000, and then it's 17% for any amount over $7,000. We want to figure out how much did he pay in taxes in total. So what you're going to also see in your homework is you're going to have a chart. So in this case, I just have 2 different brackets. The first bracket is between $0 and $7,000. Now, the very next amount, because we're dealing with money, would be 7,001 cents. And then this goes on to the end amount, okay? So anything that falls in this first range is taxed at 15%. Anything that falls into the second range is then taxed at 17%. So Dion making $8,000 falls into the second range. If I only made $5,000, it would fall into this category and I would just have to pay 15%. But because we're in the second category, my money has to get split. So the first $7,000 he makes is taxed at 15%. Okay. So for him, then the money that's left untaxed is the difference between these two. He made $8,000. $7,000 has already been taxed. So he has $1,000 in his income left to be taxed. And this $1,000 will be taxed at that 17% rate. Okay? So he's not taking his $7,000 and timesing it by 0.17. He's splitting his money into these categories. If there was a third one, same idea. Whatever money falls into the first category, taxed at that first rate. Whatever money falls into the second category is taxed at that rate. And then however much is left over that hasn't been taxed is taxed at the third rate. Okay? So if we go and calculate these then, his first $7,000 is taxed at 15%. So we want to take $7,000 and multiply it by 0.15. So on his first $7,000, he's going to owe $1,050. Okay. Now again, he had $1,000 more that was untaxed. So his taxes on that $1,000 are going to be 17% of $1,000. So we take $1,000 and times it by 0.17. So on this $1,000, he's going to pay $170. Okay. So his total taxes then are just the sum of these two. So his total taxes is $1,050 plus $170. So in total, Deon's going to be paying $1,220 in taxes. So again, you can go look at the IRS's website. The buckets, though, however, on this side are not as nice. It's like 0 to, I don't remember the first number, but like $15,241. It's very different amounts, okay? But if there was another category to just kind of give you an idea, maybe this went to $10,000. And then you had a third category, like 10,001 cents to so on. If you made 12 grand, the first 7,000 would be taxed at 15%. Then within this bucket is $3,000. $3,000 would be taxed at 17%. And then if you made 12,000, you have $2,000 more untaxed. That would be taxed at whatever this rate is.